Alright, so we're going to pick up where we left off with section 6.3a. We're going to do 6.3b now, which is graphing transformations of exponential functions. So not just like 2 to the x, but more stuff added into that 2 to the x, like 2 to the x minus 4, 3 times 2 to the x, and other things. So linear transformations of it, well, multiplication or addition. So that's our one learning target. We've got a few examples. This might be a little bit of a long video. Feel free to kind of bounce around as you need. Boom. All right, we're going to start with a few examples. As always, we're going to graph the function. We're going to describe the transformations. We're going to talk about the asymptotes, domain, and range, that sort of thing. So here we have 3 times 2 to the x. So remember, if I have x, y, if I just have y equals 2 to the x, 2, 3, 0, 1, 2, 3, 1, 2, 3. If this is just 2 to the x for y, it's 1, 2, 4, 8. The y numbers are just doubling as each time x gets bigger by 1, the y number doubles because it's 2 to the x, we'll multiply by 2. Here, as x gets smaller, as it goes negative. If x goes minus 1, y goes divide by 2, or multiply by a half. Because a negative exponent means divide instead of multiply. So here we have 3 times 2 to the x. So this is 3. So if I have 3 times 2 to the x, I'm going to write this here, x, 2 to the x, and then 3 times 2 to the x. So 0, 2 to the 0 is 1, and then if I have 3 times 2 to the x, it's just 3 times that, so it's just 3. If I have x equals 1, right, like we had there, 2, 2, 3, right, 4, 8. I'm just putting in the 2 to the x values here. Again, I should have done that instead, but that's fine. 1/4, 1/8. This is 2 to the x. 3 times 2 to the x is just 3 times each of these numbers. So here I'm going to get 3, I'm going to get 6, 3 times 4 is 12, 3 times 8 is 24. Here I'm just going to write it as 3 over 2. Write this as 3 over 4. And 3 over 8. So we'll notice, like, what's the pattern here? The pattern is still times 2. If we go this way, as x gets larger, we're multiplying by 2. As x gets smaller, we're dividing by 2, right? Or we're multiplying the denominator by 2. So here, if we're going to graph this, or else keep this as, let's go by, oh, we can go by 2s here. So let's go 2, 4, 6, 8, 10, 6, 8, 20, 2, 4, 6, 8, 30. All right, so this is 24 right there. We're at 1, 2, 3, negative 1, negative 2, negative 3. We're just going to take each of these as a point. So like negative 3, comma 3/8 would be a point on 3 times 2 to the x. So negative 3 and 3/8. 3/8 is an eighth smaller than 4/8, so it's like a little less than a half. So it's right down here. Boop. Negative 2 is at 3/4, so it's almost at 1. Remember, we're going by 2s here. 3 over 2 is 1.5, so it's right there. When we're at 1, we're at 3. When we're at, oh, sorry, when we're at 0, we're at 3. That's why I graphed there. When we're at 1, because here we're just kind of ignoring this. We're just picking these. This is 1, comma 6. 2, comma 12, and 3, comma 24. Connect the curve. Notice the y values are still doubling, right? 3, 6, 12, 24, still getting multiplied by 2. The difference here is our y-intercept. The y-intercept is now at 0, comma 3, or it's 0, comma that number right there. It's not always going to be the case. We'll see that here. But if you just have y equals a times b to the x, something times b to the x, that something is how far off of that asymptote you're going to start. This distance from the asymptote is 3 right here. From 0 to 3 is 3. So here, asymptote once again is at y equals 0. Because all we're doing with this is we're just tripling the outputs. It's 3 times 2 to the x. So it's just taking this graph, taking all the previous y numbers from just 2 to the x, and tripling them. So the asymptote is y equals 0. The domain is all real numbers. And the range is still y is greater than 0. Now the transformation we call this a vertical stretch. You could also call it a dilation. Some people call it vertical dilation by a factor of 2. Nope. Factor of 3. A factor of 3 because the number we're multiplying is a 3. So it could be a vertical stretch by a factor of 4 if it was 4 times 2 to the x. If this number was smaller than 3, like let's say it was a half, that would be a vertical shrink, or it's still, you say, a vertical dilation in that case. You just have to say by a factor of whatever that number is. All right, essentially that number multiplied out front, all it does is it takes your original function. In this case, the original function was 2 to the x, and it just takes all the y numbers, multiplies them by 3. So if you know all of these already in the top of your head, which hopefully when you do enough of this practice you will, if you know all those, you can just multiply them all by 3 and graph them. Okay. Let's move on to 2 to the x minus 4. So 2 to the x minus 4, using this, what's happening here is we're just subtracting 4 from all of these 2 to the x answers. So from all of those. So if I have the same x's, so let's say we have x, and then here I have 2 to the x minus 4 as my y. So negative 3, negative 2, negative 1, 0, 1, 2, 3. I'm going to go 1 minus 4 is negative 3. 2 minus 4, negative 2. 4 minus 4, 0. 8 minus 4, 4. Here, a half minus 4 is negative 3.5. A quarter minus 4 is negative 3.75. An eighth minus 4 is what? I don't remember. It's like 0.125, so it doesn't matter. But it's negative 3 7/8. So it's almost negative 4, basically. It's about. So what's happening here is all of my y values from my original function, 2 to the x, the original would just be 2 to the x, they got 4 taken away from them. And what this is going to do to the graph is it's going to take that whole graph and it's going to shift it or translate it down 4 units. So here, if I'm just going to graph these points. So I have 0, negative 3, 1, 2, 3, 0, negative 3 right there. And then I have 1, negative 2 right there. And I'm keeping my scale just by ones this time. So 2, 0, that's right there. 3, 4, right there. And then here I have negative 1, negative 3.5. So halfway between negative 3 and negative 4. So negative 3, negative 4. Here I have negative 3.75 with my negative 2 for my x. When x is negative 3, I'm at negative 3 7/8. So getting really close to that negative 4 there. So here my graph looks like that. Whoop, it's going up. And right here, we're seeing this flatten off on this curve here. And basically what's happening here is I'm taking my original function, which was just 2 to the x, right? Remember, it looks like this. I was taking this green function, this is just y equals 2 to the x. I was taking that whole thing, and I'm subtracting 4 from all the y values. So I'm picking it up, plopping it down 4 units. Now, the original asymptote for y equals 2 to the x is at y equals 0. Now, if I take away, so y equals 2 to the x, asymptote is y equals 0. If I have y equals 2 to the x minus 4, the asymptote is y equals 0 minus 4, which is negative 4. So here, the asymptote here is y equals negative 4. And the way to graph this, because it's no longer on that y equals 0, it's no longer on that x-axis, we draw a dashed horizontal line. A dashed line in math represents an asymptote, usually. If there is an asymptote, we represent it with a dashed line. That's saying that graph is getting arbitrarily close to that line, but it's never actually going to equal that line. Now, domain for all these functions, these ones, domain is all real numbers. Domain, all real numbers. We're not changing anything on the x, we're just changing the y values with that -4. So the range, though, the range is it's going to get a little more interesting now. Instead of having all these y numbers like on this green graph that are above 0, we now get really, really close to -4, which means we have all the numbers above 0, but we've got 0 too, right? When x is 2, y is 0 for this function. And then as x goes smaller, we get all of these negative outputs, like -1, -2, -3, and all the decimal values in between. And then as we approach -4, we get closer and closer and closer to -4, the same way we get closer and closer to 0 on this graph, but we never quite get there. So here, our range is all the y numbers that are bigger than -4. Okay. So I'm going to erase this green graph, this y equals 2 to the x. I'm going to keep this graph up, though. This graph is y equals 2 to the x minus 4. Now we're going to look at y equals 3 times 2 to the x minus 4. So this is this function, 3 times 2 to the x, but then 4 taken away. So I'm going to make a little table here, x and y. And what I'm going to do is I'm going to use each of these numbers, and I'm going to subtract 4 from each of them. So, -3, -2, -1, 0, 1, 2, 3. Whoop, 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 whoop. So when x is 0, y used to be 3 for this function. So 3 times 2 to the 0 is 3. Take 4 away from that, we get -1. We're just subtracting 4 from these because if I go -4, right, 3 times 2 to the x and then -4, that's this. So I'm just subtracting subtracting